Have you ever wondered, what if there were planets completely covered by oceans? No mountains, no continents, no solid ground at all. Just water. Water as far as the eye, or the telescope, can see. It sounds like science fiction, but the truth is, this possibility isn't just taken seriously. It might be closer than we think. Astronomers around the world are searching for these exotic worlds, and recent data shows they might be more common than we ever imagined. Today, we're diving deep into this cosmic mystery. We'll explore ocean worlds, planets that may be hiding forms of life unlike anything we know. And the best part, they could be much closer to us than the stars let on. Get ready, because this video will take you to a place where every drop of water might hide an entire universe. Ocean planets, or ocean worlds, are exactly what the name suggests. Planets completely covered in liquid water. And not just a little, we're talking oceans hundreds of kilometers deep. For context, the deepest part of Earth's ocean is only about 11 kilometers. These planets might have formed far from their stars, too far for liquid water typically. But with thick atmospheres or intense geological activity, they can still hold on to that water in liquid form. What's fascinating is that these worlds don't resemble Earth much. Many lack tectonic plates or any real surface variation. They're nearly perfect spheres, with oceans that never touch the bottom. Some may even have layers of ice above or below the water. That's why scientists classify them into multiple types: warm ocean worlds, cold ones, shallow, deep, and even those hiding underground seas. We've never landed on an ocean planet. We haven't even seen one up close, but the clues are there, hidden in data, graphs, and faint dips of light. Space telescopes like Kepler and James Webb observe stars for dimming. When a planet passes in front, we call it a transit. From that drop in brightness, scientists can estimate a planet's size. Combine that with mass, measured another way, and you get density. If a planet is large but strangely low in density, like a massive ball of styrofoam, that's a red flag. It could be made mostly of water, and there's more. Sometimes a planet's atmosphere leaves a chemical signature in the starlight that passes through it. Spectrometers can detect traces of water vapor, even from hundreds of light years away. Each new clue is a puzzle piece, slowly revealing worlds we can't yet see, but know are out there. Picture a world with no solid ground, no mountains, no forests, no deserts, just an endless ocean, blue horizons in every direction, and a surface that never stays still. If humanity ever colonized an ocean planet, life there would require extreme adaptation. All infrastructure would need to float or be built on mobile platforms. Research bases, colonies, even entire cities, amphibious or submerged. Gravity might be different from Earth's, affecting everything from blood circulation to how people move. With no islands or continents, all transport would be by sea or air. But here's the most fascinating part. What kind of marine life would evolve on a planet like this? In an ocean hundreds of kilometers deep, life forms would need to survive in complete darkness, under immense pressure. And who knows, maybe even develop intelligence. Water is one of the most common elements in the universe, and yet one of its greatest mysteries. How did it spread so widely? And why does it seem to be so closely tied to life? Astronomers have found water vapor in interstellar clouds, in dusty disks around newborn stars, and even on exoplanets thousands of light years from Earth. Most amazing of all, we found ice on Jupiter's and Saturn's moons, and on comets roaming the deep cosmos. Many scientists believe Earth's water came from those very comets, cosmic messengers carrying the building blocks of life. If that's true, our oceans are literally made of star stuff. And in the context of ocean planets, this raises a massive question. Is life common out there? Because where there's water, there might be life. Detecting an ocean planet beyond our solar system is nearly impossible, at least with the tech we have today. Most of these worlds are hundreds or thousands of light years away, and all we can observe are tiny shifts in starlight. These shifts, caused when a planet crosses in front of its star, tell us its size, orbit, and sometimes hints about its atmosphere. But knowing if it's a true ocean world? That's another story entirely. A planet's density can give us clues. A world that's too light for its size may be made mostly of water. But even then, that doesn't prove it's covered in oceans. It's like solving a cosmic puzzle with half the pieces missing. Still, some candidates are already standing out and pushing us toward a new generation of telescopes that could change everything. Out of the thousands of exoplanets cataloged, so far, a few are suspected of hiding global oceans, beneath the surface or even on top, as true aquatic worlds. One of the most promising is TOI 1452b. It's about 100 light-years away and larger than Earth. But what stands out is its density. Far too low to be a rocky planet, scientists believe it could be covered by a massive ocean, possibly hundreds of kilometers deep. Another possible candidate is Kepler 22b. It orbits its star in the habitable zone, and while we don't yet know its exact composition, it's just the right size to support liquid water, maybe even in the form of oceans. These planets might be just the tip of the iceberg. With better telescopes, it's only a matter of time before we find out if they're true ocean planets or just cosmic imposters. Landing on a water-covered planet wouldn't be anything like touching down on the Moon or Mars. Forget solid ground. The surface would be liquid, deep, and often hostile. First, atmospheric entry, a brutal dive with extreme heat and pressure. Any spacecraft would need to be more like a submarine than a lander. That's because below the surface, pressure skyrockets. Every kilometer down multiplies the challenge. Sunlight would likely only reach the upper layers. Below that, a dark, freezing abyss. But here's the most intriguing part. What if there's life down there? Adapted to total darkness, maybe bioluminescent, truly alien. You can't walk on an ocean planet, but you can explore it with aquatic drones, autonomous probes, and a ton of bravery. And maybe, not too far in the future, we'll witness the first interplanetary dive in human history. The next generation of space telescopes won't just look for planets. They'll analyze their atmospheres in insane detail. That means we'll be able to spot indirect signs of oceans, water vapor, constant cloud cover, or specific light reflections. Future missions like LAVOIR and HABEX, planned for the coming decades, are set to hunt these worlds with precision that feels like sci-fi. And it's not just about telescopes. New starlight blocking techniques, like starshade, a massive disk that blocks out a star's light, will let us directly observe light bouncing off tiny distant planets. These technologies might finally confirm what we've only suspected, that ocean worlds aren't rare. They might be common, and the more we find, the louder the question gets. Are we really alone in this cosmic sea? If ocean worlds are common, the question shifts. It becomes a demand. Then why is everything so quiet? That's the paradox. More oceans should mean more chances for life, and yet, the universe feels silent. No signals, not a whisper. One explanation? Maybe aquatic civilizations evolved differently. Maybe living underwater limits the kind of technology we developed. No fire, no electricity, at least not like ours. Or maybe they're out there just silent by choice, watching or hiding. The silence of space stops feeling empty. It starts to feel intentional. On ocean-covered planets, water isn't just an element, it's an architect. The gravity of a deep global ocean can reshape the crust, trigger insane tides, and even generate internal heat. Yes, in distant worlds, water becomes a geological force. With no continents to break the flow, currents can circle the entire planet non-stop. That creates a climate engine so massive it redistributes heat, influences the magnetic field, and maybe even decides if life can exist. The interaction between deep seas and the core might produce something we've never seen before. Century-long storms, waves that cross entire hemispheres, and underwater regions hotter than the surface. It's not an exaggeration to say that in these worlds, the ocean is the planet. It defines the physics, the chemistry, maybe even the biology. A sea with no shore and secrets Earth could never imagine. Both If there's one central question about ocean worlds, it's this: how does water remain there, stable, liquid, and abundant? After all, it's not enough for water to exist. It needs to stay in liquid form for millions, maybe billions, of years for a planet to truly be considered habitable or scientifically fascinating. And the answer starts with something fundamental: gravity. On ocean planets, gravity acts like a silent guardian of water. If it's too weak, the planet can't hold on to its atmosphere, and without that, it quickly loses the volatile elements like hydrogen and oxygen that make water possible. But if gravity is too strong, surface pressures can be so intense that liquid water turns into exotic ice, even at temperatures above freezing. We're talking about forms like Ice 7, which don't exist naturally on Earth. Water, by nature, is incredibly sensitive to pressure and temperature. So these ocean worlds need to exist in a very narrow window of balance, where gravity is strong enough to retain a thick atmosphere, but not so strong that it crushes water into ice at the surface. Another crucial factor is temperature, both external and internal. A planet orbiting too close to its star risks something called photodissociation. UV radiation breaks water molecules into hydrogen and oxygen, and the hydrogen escapes into space. This likely happened on Venus, which may have had shallow oceans in the distant past, but without a magnetic field, and being so close to the sun, Venus lost its water completely. Planets farther out, especially those orbiting cool red dwarf stars, rely on internal heating, like geological or radioactive activity, to keep their oceans from freezing. This internal energy can also form thick ice shells over subsurface oceans, just like we see on Europa or Enceladus. These icy layers shield the liquid water from stellar radiation and prevent direct evaporation. Now let's talk atmosphere. It's not just for breathing. It acts like a thermal blanket and a radiation shield. Atmospheres rich in carbon dioxide, methane, or water vapor can trap heat and maintain surface temperatures in the sweet spot for liquid water. But it's a delicate balance. If a planet gradually loses its atmosphere to solar wind, it enters thermal collapse, and eventually its oceans vanish. Just like what happened to Mars. That's where a magnetic field becomes crucial. It's the invisible shield that protects a planet's atmosphere from being stripped away by solar wind. On ocean planets, an active metal core can power a magnetic dynamo, preserving this protective barrier over the long term. So scientists now believe that long-lasting oceans depend on a finely tuned combination of factors: the right mass, a stable orbit, a thick and protected atmosphere, internal heating, and the right distance from its star. If any piece of this puzzle fails, water will eventually evaporate, freeze, or simply disappear. And here's something mind-blowing. Most of the water on ocean worlds isn't even at the surface. In many cases, the oceans are hidden beneath miles of ice trapped under extreme pressure. These subsurface oceans may contain more water than all of Earth's oceans combined, but they're completely invisible from space. The water's there, it's just locked away in a world beneath the ice. So when we find liquid water on an exoplanet, it's not the end of the story, it's just the beginning. The real question is, how long will it last? If the idea of hidden oceans, water-covered alien worlds, and the silent struggle to keep liquid water in place blew your mind, just imagine what else is out there. There's an entire universe of strange planets waiting to be discovered, and we're just getting started. So hit that subscribe button, drop a comment with the wildest space theory you've ever heard, and turn on notifications, because the next discovery might be even more unbelievable. See you on our next journey into the unknown.